Very basic welding blueprint reading. If you have a joint set up like this in a T, and I'm your employer and I give it to you and walk away, how do you know where to put the weld, how big, what process to use? You look at the print, and welding has its own set of special notations on blueprints.
Lincoln puts out this fantastic poster that shows different joint orientations and different symbol notations. This is a weld symbol, and it has everything on it. This is a key. This is overwhelming. I wouldn't give this to a beginner. I would post this somewhere so that you could reference it to see what the heck your print actually says. To me, this is the best example of how a weld symbol is used. If I gave you those two pieces of material, if you cut them in cross section, this is what you would see. Where do I want the weld? Do I want it on this side or that side or both? This symbol is telling you, because the triangle is above the line, that it is to go on the other side of the arrow, so across from it. If it were hanging off to the bottom, if the triangle were pointing downward and there was nothing up here, that would mean arrow side. And since the arrow is pointing to this area of the joint, your weld would go along in here. If you had a triangle on top and bottom, that means weld both sides. It seems a little counterintuitive at first. Above the line, other side, below the line, arrow side. Here's an example of a tricky test question I remember getting when I was in college, and so it's one that I give, my new welders too. If there's a joint orientation like this, you got one plate here, one up and one down, and you've got a symbol that says, put a weld on the other side. Well, where do you put it? It looks like there are 3 other sides, but there's only one answer to this. And the answer is the same as what I saw over in the poster, over here, because it's pointing to this joint, the joining of this piece to this piece. It's not pointing to these two. This joint here is kind of irrelevant. So it says, fillet weld, other side from the arrow on this joint fit up. You would put your weld in here. Here's an isometric view of a chunk of square tubing put on a plate if I wanted you to weld all the way around it. Sorry, my phone filled up. I had to switch over to TikTok recording. So if you wanted to weld all the way around this piece, I would draw you a view from the front or the side. There's the square tubing sitting on the plate there, and there's the weld symbol. We stick an all around on it. And that notes that your start and your stop, it goes around the entire perimeter of this weld joint. I think pipe is exempt from this. I'd have to look it up. There are a bunch of different types of welds that you can do, like over a dozen, and there's several welding processes that you can use. And finishes, do you want a bead profile? Do you want a convex or a concave bead profile? For whatever reason, for whatever the part, whatever the strains on that part are going to be, you might want a different profile. Do you want it ground flat or sanded flush? What kind of profile, what kind of finish you want to put on it. There are all kinds of information stored inside these little symbols, but that is how welders know what to do. And when you get on a complex project with a lot of different parts, they can get quite involved. But it's not daunting. There's always someone there to give you help or give you a bit of a hard time, and then give you help if you need it. The important part is to know how to use a tape measure and a square, and know how to make the piece that you are putting in front of you within tolerance of what that blueprint says, because you can't move steel very well. I mean, steel is actually surprisingly mobile when you get it big enough. But if you are a fabricator who works on a bench or you're doing a small part, you really have to be fairly critical with your measurements, and then also account for it maybe moving with the heat of your weld. After a while, you get really good at knowing exactly how much heat it takes to move one piece just this far, so you can offset it during your fit up, so that when you weld it, it pulls it into where you want it to be, and you don't have to beat it into submission, although we do that pretty routinely as well. P.S. Everything is a hammer. I am Ann. Thank you for coming to my weld talk this morning.